याद रखना. Okay, so this way I can actually understand how to represent a CSP. To represent a CSP, I should define three things. One is number of variables that define my state should be clear to me. So I should know when I'm using CSP to solve a problem, I should know the state of the problem completely. अगर partial observable scenario है, I should not use constraint satisfaction problem because I won't be able to define the state completely. तो स्टेट को अगर मैं प्रॉपरली रिप्रेजेंट कर सकता हूं तो वो प्रॉब्लम में मैं सीएसपी तरीके से रिप्रेजेंटेशन करना चूज कर सकता हूं. दैट्स द फर्स्ट आइडिया. I should be able to break down the state into the different variables or different properties, and those properties domains should also be properly defined. They may be same, they may be different, it all depends on the problem that you are solving. In this case of the problem, map coloring problem, our domain is fixed, so the color palette is given to us. Okay, what about the third thing that I require to represent a CSP problem? That is called as constraints. So constraint is the third and important thing that I require to define a CSP problem. Constraints tell us what is a valid assignment and what is, or rather what is the consistent assignment and what is not a consistent assignment. Constraint always mix multiple variables together as per the domain values, and they define certain relational check on these multiple variables. So there are different types of constraint. Some of the constraint may be unary, where they are dependent on a single variable. Okay, in this problem, checking whether every region is colored colored with a color from the palette is a unary constraint. So I will just pick up Western Australia and check whether the color of the Western Australia is red, green, blue, any one of them. Okay, so that's a unary constraint. Okay, binary constraint on the other hand would involve two variables. Just like WA not equal to NT, I'm picking up two variables, WA and NT, checking their values whether they are equal or not. So that is a binary constraint. Similarly, there would be n-ary constraint involving n number of variables. Okay, so that is how the different types of constraints can be there in the graph coloring problem. There are still more different ways to have the constraint also. Now there is another concept called as constraint graph that we need to understand. Okay, what exactly is the constraint graph? Constraint graph means if from the given problem definition, so this is my problem definition, right? I have this map given to me. This is my problem definition. If I try to represent all the constraints that are there for the given problem in terms of a graphical representation or a graph data structure based representation. So this is a graph data structure. You will see here that I have these nodes as my different regions in the problem, or different variables I should say in the problem. So nodes are variables, arcs are nothing but the constraint. So I'm attaching WA with NT because WA and NT are adjacent regions. WA and SA are adjacent region. SA is adjacent to all other regions but Tasmania, and Tasmania is not connected to any of the regions in the graph, and that's why it is an kind of island region. Okay, it is an isolated region, I should say. So this graph that you're looking at tries to represent all the kinds of constraints that are posed on the given problem. The constraint here is adjacent region should be colored differently. So ये constraint graph मुझे बता रहा है कि W and NT they participate in a binary constraint. NT and Q participate in a binary constraint. Q and SA binary constraint. Okay, so a binary CSP is a CSP where all the constraints relate to two variables. All the constraints relate to two variables. There is no constraint which is having more than two variables tested for. Okay, so constraint graph is composed of nodes, composed of arcs. Nodes are variables and arcs are constraint. Okay, WANT should be different color. ये arc मुझे बता रहा है क्योंकि WANT connected है ये graph में, constraint graph में they are connected means they must possess different colors. That is what this particular ग्राफ से. सो ग्राफ अगर मैं ड्रॉ करता हूँ, कंस्ट्रेंट ग्राफ में अगर ड्रॉ करता हूँ, तो मुझे क्या पता चलता है? आई गेट टू नो अ बिट अबाउट what type of constraints we are having in the problem. Are they unary? Are they binary? Are they ternary? Are they n-ary? What kind of constraints are there? And based on that, I can choose for a respective. I can choose for a respective solution technique. So I can base my selection of respective solution technique based on this particular understanding that I obtained from constraint graph. So why I require constraint graph? Constraint graph basically is not very much important in providing you the solution or writing the solution algorithm, but to choose the solution technique, that will help you. Constraint graph will help you to choose a solution technique, because it will be classifying your CSP problem into a type of CSP problem. Just like in this case, it is been classified as a binary CSP problem where every constraint is relating to variables. So I should choose a technique that is good enough for such problems to be solved. Okay, so that is how you should try and understand this topic. Finally, what are different varieties of CSPs? What is the time? It's 51. Okay. You can put your roll numbers in the chat window. We'll stop after 4 minutes. I guess one more slide we'll do, and then we'll stop because I have another lecture today right after this lecture, and I require a bit of breather in between. So we'll just see one slide and we'll stop the session. Okay. So what are the different varieties of CSP? So in the CSPs, to have different CSPs classified into, we define them based on constraint, different types of constraint as well, and different types of variables as well. So I may have for certain CSPs variables that are discrete or variables that are continuous. So based on variables, I can classify CSPs into two categories. A category that is called as having discrete variables, and the second category where the variables are having continuous domain. So the domain of the variables decide what kind of CSP you are having. So I may have variables in a CSP that have discrete domains. That means I may have a domain of, I may have n variables, and every variable has a certain domain size, that is D. Okay. So a complete assignment. So how many complete assignment can be there with a n variable D domain size sized CSP? There will be big O of D raised to n, where D is the domain size. D is the domain size means what? Every variable. So say suppose there are three variables I have. Sorry, there are three variables that I have. Maybe variable 1, variable 2, and variable 3, and all are discrete variables. All are coming from same domain. All values are coming from same domain, and those that domain is say suppose 1, 2, 3. Or I should say, take the same example, the graph coloring one. So here I had how many variables? 7 variables were there, and there were 3 colors. So instead of writing color names, I'm coding them with numbers just for the sake of understanding. Maybe you should consider. So 7 variables are there. So n is 7, and domain has value 3 for each variable. Okay, so this is the average value of domain, or I should say it could be maximum value. If I'm having every variable certain different domains for a particular problem, then I should say that I would take the maximum value out of it. So maximum domain size मैं लूंगा वो 3 है, discrete variables है, variables का domain discrete है, 3 values है यहाँ पे, 7 raised to 3 number of complete assignments I would be getting, right? अगर मैं complete assignment कितने होंगे ये काउंट करूंगा तो वो 7:3 होंगे. This is a very large number, but how many of them will be consistent? The consistent assignment will be very few. The consistent assignment will be very few. Okay, and that is why it is a non-polynomial time complete problem. No, non-polynomial time because See the order is d raised to n, where n is the size of variables. So if there are more variables, so n is the input size here, input size. So I am exponentially increasing the amount of time required to know how many. So मैं ultimately क्या कर रहा हूँ, out of these 7⁻³ जितने सारे 7 × 7 × 7 जितने मेरे कंप्लीट असाइनमेंट है, वो मैं एक एक करते चेक कर सकता हूँ वर्स्ट केस में, and then I would obtain one of the valid or complete assignment, one of the consistent assignment. That would be the goal test satisfaction criteria. That will be the goal test satisfaction criteria. So that is why in a worst case scenario, Boolean CSP would be NP complete problem. N variables, T domain size, the count of complete assignment is d raised to n. That is big O, d raised to n is the order of checkings that I would require in order to get the solution instance. Okay, we'll talk more about this in the upcoming lecture.